So let's look at where these double angle identities come from. They're pretty commonly used. I feel like the sine one and the cosine one are used quite a bit. The cosine one, really the only one I've memorized is the top one. The other two come out of using the sine squared plus cosine squared equals 1 rule. Um, and then the tangent one I never bother memorizing because I always just turn tan u into sine 2. Tan 2u is the same as sine 2u over cosine 2u anyway. But you could simplify it to the thing that's there. So anyway, let's look at sine 2u and figure out where that comes from. Well, sine 2u is really the same thing as sine of u plus u. And we learned from our from our angle sum formula that if I have a sine alpha plus a beta, that's going to be the same thing as, let's see, it's sine alpha cosine beta plus cosine alpha sine beta. So really all I need to do is make alpha and beta both u, and then I've got sine of 2u. So this thing right here is going to turn into sine of u cosine of u plus cosine of u sine of u. And if you think about it, well, that's really just 2 sine u cosine u's. Right, so there we go. There's proof. The second one, cosine 2u, you could do this two ways. You could approach it by solving... no, actually, let me not do it that way. That'll take too long. So let's do this. Cosine 2u, let's solve it the same way that we solved the sine one. Let's look at what cosine alpha plus beta is. If you remember the angle sum formula for this one, it's cos alpha cos beta minus sine alpha sine beta. So if I just make alpha beta both u's, then I've got cosine of u plus u equals cosine u minus sine u sine u. Whoops. And that's going to be cos squared u minus sine squared u. So now we've taken care of these two. I'm not going to bother proving the tangent one. If you wanted to prove, let's say, this one, well, notice the second term's a 1. Well, in this one, I could get the second term to be 1, or this term to turn into a 1, if I switch out sine for 1 minus cosine squared, right? That's sine squared for 1 minus cosine squared. If I do that, then I'll end up with this, which turns into 2 cosine squared u minus 1. And you could do the same sort of thing if I replaced that term with 1 minus sine squared instead. You'd get this version of the cosine 2u. And then you can memorize this one if you want. But really, you know, if you can figure out what sine 2u and cosine 2u are, then it's just, then that's one less formula you have to memorize. So, okay, hope that helps.